Welcome to the deep dive. Today, our mission is a really interesting one. We're looking at K-EXAONE, the large-scale model from LGAI Research.
hmm
And what's compelling here is that this isn't just about a new model. It's really a story about strategy, about how South Korea is trying to compete in this, intense global LLM race.
Right, despite facing some major infrastructure challenges.
Exactly. The GPU shortages, the lack of specialized data centers, all of that.
And that's the thing, when you can't just, outspend everyone on hardware, you have to be smarter. You have to out-engineer them.
So the government stepped in.
They did, yeah. They launched a strategic program to secure resources, like GPUs, but the model itself, at its core, had to be incredibly efficient just to bridge that gap. K-EXAONE is really a great example of innovation that's born from scarcity.
Okay, so let's unpack that efficiency. It starts with the architecture, right? A mixture of experts or MOE design.
That's right. The model is huge. I mean, 236 billion total parameters.
Yeah.
But, and this is the key, only a small fraction of that, about 23 billion, is actually active during inference. So you get the power of a giant model without the massive computational cost every single time.
I see. And they also focused on speed, not just size.
Exactly. They added something called the Multi-Token Prediction Module, or MTP. If MOE is about capacity, you can think of MTP as being about quickness.
So what does that actually do?
It's sort of a self-drafting mechanism.
Yeah.
Lets the model predict several steps ahead instead of just one token at a time. And that boosts the decoding speed by about 1.5 times when you're using it.
Okay, so that's the efficiency piece. But the other side of this is sheer scale. It's
Right.
memory, right? A 256K token context window, that's pushing the industry maximum.
It's an incredible number. And getting there wasn't simple. It took a two-stage process, essentially training the model to handle larger and larger documents, first from 8K up to 32K,
And then the big jump.
and then the big jump all the way to 256K.
But wait, doesn't stretching a model's memory that far cause it to sort of forget how to handle simple, short questions?
That is a critical concern, and they thought about it directly. To prevent that kind of performance drop on short context tasks, they used what they called a rehearsal data set.
Like flashcards.
Pretty much. Think of it like a core curriculum. While it's learning to handle these huge documents, the model is constantly rehearsing high-quality short samples to keep its fundamental skills sharp.
So with all that power and efficiency, how does it actually perform?
It's very competitive. In its reasoning mode, it hits a score of 83.8 on MMLU Pro-O and a really striking 92.8 on the AIM 2025 math benchmark.
So it's often leading other open weight models there.
It is. And its multilingual capability is really strong, too. It covers 6 languages, Korean, of course, but also English, Spanish, German, Japanese, and Vietnamese.
And it's balanced across them.
Very balanced, yeah. It scored an average of 90.5 on the WMT24 plus translation benchmark, which suggests a deep, genuine multilingual ability.
This brings us to what I think is the real aha moment here, the thing that truly sets K-EXAONE apart, its approach to safety.
All right, everyone's focused on universal ethics, but LGAI Research built an in-house benchmark called KGC Safety.
And this is built on a specific framework.
It is. It's called the Korea Augmented Universal Taxonomy, or KAUT. And this is where the regional strategy becomes so clear. It doesn't just use standard ethical principles, it actually merges them with specific Korean cultural and geopolitical sensitivities.
That sounds incredibly complex. Can you give us a concrete example of what a risk under that kind of augmentation looks like?
A perfect one is under their Korean sensitivity domain. KXNT addresses specific localized risks, like discrimination against North Korean defectors,
Oh, wow.
and things like historical distortions. These aren't just vague ideas. They require the model to adhere to domestic laws and verified historical facts, and it works. KXON gets a safe rate of 96.1% on this benchmark.
So what does this all mean for you? K-EXAONE is really defined by 3 pillars. That super efficient MOE scaling, the huge 256K long context capability, and, critically, this culturally augmented safety.
And if you want to use it, the model is available under both commercial and non-commercial licenses. But you do have to agree to some strict ethical rules. No fraud, no harmful content. And importantly, LGAI Research claims no ownership over anything you generate.
So here's the final thought. The integration of this kind of cultural specificity into AI safety through a framework like KAUT, it really changes how we have to think about responsible AI. If every major language model needed to incorporate these kinds of deeply nuanced regional and historical sensitivities to be considered safe, what would the next truly universal ethical AI framework even look like? Something for you to chew on as you continue your deep dive.